Today we're going to look at a few examples of exponential modeling or using exponential functions in a real-world situation. So, I don't know if I'm going to say this right. Technetium, I don't know. 99M is a drug taken by a patient and then used to study tumors in the brain, lungs, and other parts of the body. A patient takes a 1,000 milligram pill. After the first 6-hour interval, 500 milligrams remain in the body. After the second 6-hour interval, 250 milligrams remain in the body. And after the third 6-hour interval, 125 milligrams of the drug remain. So it first asked us, what is the initial value? Well, when the patient takes the pill, the initial value is 1,000 milligrams. What is the growth or decay factor? Well, we're going from 1,000 to 500 to 125. So you can probably already see that we're having here. But to find the growth or decay factor, we would take the second value and divide by the first. You can see we get 1/2. And then take the third value and divide by the second, and so forth. You should get the same number each time. So the growth factor is, I wrote that wrong, didn't I? Let's see. 250 and then 125. Okay, there we go. Sorry about that. But anyway, it is still 1/2 our growth factor. Write a rule for the function. Well, our exponential functions will be in the form a times b to the x, where a is the initial value and b is the growth or decay factor. So for this one, we plug in an initial value of 1,000, and the growth factor or decay factor in this case is 1/2 to the x. So that would be our rule for the function. And then it asks how much of the drug will remain after 5 6-hour intervals. So we would just plug in f of 5. And we get 31.25 milligrams. The next example says, in television shows and movies, you often see scientists studying patterns of data, like growth of zombies, bacteria, or etc. Okay, so below is a table that shows the number of zombies. This is what this book picked, okay, not me, over a 4-day period. So as we can see, we are getting exponentially more zombies. On day one, the initial day, there were only 2. After the first day, there's 8, then 32, 128, and 512. That's a lot of zombies. So what is the initial value? The initial value is, again, the value on the first day, which is day 0. So 2 zombies. What is the growth or decay factor? So let's see. If we'll take the second and divide by the first, we get 4. If we take the third and divide by the second, we get 4. Let's try one more time. Let's take the fourth and divide by the third. You also get 4. So the growth factor is 4. Now we can write a rule for this function where the initial value is 2 and the growth factor is 4 to the x. How many zombies will there be in a week? A week is 7 days. We're talking in days here, so we need to plug in 7. Do not, when you do this, don't multiply 2 times 4. Because by order of operations, we have to do 4 to the 7th power and then multiply by 2. Oh my goodness, there's going to be 32,768 zombies after a week. That is not good. In our next example, we are given 18 grams of barium-137M, which you weigh at 3-minute intervals. If the half-life of barium-137M is 3 minutes, find the amount after 12 minutes. Now, our general rule here is your initial value times 1/2, because half-life is always going to be 1/2, to the t divided by t. Now here, big T is the amount of time for your half-life to happen. It's kind of hard to write that. But in this case, we'll have our initial value was 18 grams. And the time that it takes to half-life is 3 minutes. So we'll put 3 in there. And then it asks for the amount after 12 minutes. So at this point, we'll plug in 12 for little t. And we get 1.125 grams of barium-137M. If you invest $10,000 into an account on January 1st, 1999, that gets 6.5% annual interest compounded daily, how much money would you have on January 1st, 2022? And ignore that E. I really don't know why it's there. Okay. So our formula for this is your initial amount, which they call P, times 1 plus R over N to the NT. R is the rate. N is the amount of times compounded per year. And T is the number of years. So our initial amount was 10,000. The rate is 6.5%. Now, you have to change that to a decimal. So multiply by 100 or move the decimal 2 places to the left. 0.065. N is how many times it's compounded per year. So if it's compounded daily, that would be 365 times per year. If it's compounded quarterly, that's 4 times a year, monthly, 12 times a year. And the other one that you'll probably see is semi-annually, that's twice per year. Also, you might see one that's compounded just annually. That would make N1. And what is T here? Well, we're going January 1st to January 1st, so that's good. We don't have to worry about months here. We'll subtract 1999 from 2022, T is 23 years. Now, I would go over and put this into Desmos. And when you put it in Desmos, one step at a time, you can copy and paste the previous answer into the next line. And it makes things a lot easier for you. You don't want to do like I'm doing here and round. But for sake of writing it for you, that's what I'm going to do. So starting with 0.065 divided by 365, that's 0.000178. Add 1 to that, you get 1.00178. But like I said, in Desmos, if the decimal keeps going, then you can just double click on it, copy, and paste down below, and that will help you get through it without having rounding error. And then 365 times 23 is 8,395. Now next, you have to do your exponent. Don't multiply by 10,000 yet. So 1.000178, and how many decimal places to 8,395 is approximately 4.45873, and however many decimal places. Multiply that by 10,000, and now you can round to the nearest cent. That's 2 decimal places. $44,587.43.